Hey guys, today we're taking a look at 1.4, which is all about solving systems of linear equations. We're going to start out by reviewing two problems, similar to what we did back in Algebra 1 with solving two variable systems, and then eventually we'll also be getting into solving some three variable systems once we get to boxes 3 and 4 in our notes today. So just as a reminder, we do have three different methods that we learned in Algebra 1 for how we can solve a system of equations. And that was solved by substitution, solved by elimination, and then solved by graphing. Remember, for a system of equations, the important thing to remember is that the variables in both of your equations, or once we get on the back side of our notes today, all of our variables, they represent the same thing in each of those equations. So if you know x in one of them, that has to be the same x that's in the second equation, and vice versa. So if we know what y is, that's the same one in both of those. So we're trying to find here values for x and y that make both of my equations true. So again, those three methods that we learned back in Algebra 1 were solved by graphing. So we would graph those two equations, find where they intersect, and that's the solution. And then our two algebraic methods that we're going to continue using this year are solved by substitution and then solved by elimination. So let's go ahead and jump into box 1, which is all about solved by substitution. So if we're solving using substitution, remember what that means is we're taking one of my variables in one of my two equations and substituting it for that same variable in my other equation. So looking at our system here for box 1, we've got 2x plus y equals 5, and then x equals y plus 1. So here we already know what x is equal to in my bottom equation. I know in that bottom equation x equals y plus 1. So in my top equation, I'm just going to substitute y plus 1 in there for that x value. I'm going to plug it right in here. When I do that, my new top equation becomes 2 times y plus 1 plus that same y is still there equals 5. So 2 parenthesis y plus 1 plus y equals 5. From here, we're just going to go ahead and solve that equation for my single variable y. I'm going to start by distributing my 2 into that parenthesis. So 2y plus 2 equals y. Nope. 2y plus 2 plus y equals 5. That gives me 3y plus 2 equals 5. Once I collect my terms, minus 2 on both sides. 3y equals 3. I divide by 3, and I get that y is positive 1. Once you have that first variable, then you just go back to one of your original two equations to plug it in to find that other variable. The nice thing about substitution here is if I go back to this top equation, that's a really dark blue. If I go back to this top equation here that I originally used for substitution, then I can plug that y value in there and get my x pretty quickly. So if I do that, I'm just going to take this 1, plug it back in there. So I know that then x equals 1 plus 1, so my x value is 2. With systems of equations, you just have to make sure your answer is an ordered pair, in this case, since there's two solutions, x comma y, or in this case, specifically 2 comma 1 would be my solution, number 1. So that's substitution. Moving on to box 2, elimination is a little bit different. In this one, what we're trying to do, since our goal is to get a single variable in a single equation, that's the only way we can solve this for a single variable, is to add or subtract our equations together in a way that cancels out a whole pair of variables. So in this case, I'm looking for a way that I can add these two equations together so that either x cancels out or y cancels out. And in this one, it seems pretty obvious, at least to me, that I want to try and get rid of my x values because they're both the same coefficient already, but one is positive and one is negative. So if I was just going to add these two equations together, because my x's have the same number for the coefficient, but with one positive and one negative, those would cancel each other out. So all I'm going to do is just add up my equations going down. X plus negative x, well, those cancel out and I don't have an x value anymore. 3y plus 2y is 5y. 4 plus 1 is 5. So pretty quickly, we have y equals 1. Just like we did in the previous problem, once we have one of my variables, I'm going to plug that number back into one of my equations to solve for x. It doesn't matter which equation you choose in this case, you'll get the same answer for either one of them. In this case, I'm going to plug that y into my top equation just because that's already just a positive x. So x plus 3 times 1 equals 1. So x plus 3 equals 1, minus 3 on both sides. And I get that x equals negative 2. Once again, I need to make sure ordered pair for my answer, negative 2 comma 1. So moving on to box 3, we're getting into the new stuff for Algebra 2. So this is a 3-variable system of equations. It has 3 variables in it, and in order to be able to solve a system, we need to have the same number of equations as we have variables. If I had three variables and only 2 equations, it would be impossible to solve that equation. Couldn't do it. So in this case, we have 3 variables, we have 3 equations. It looks super intimidating and scary. But the good news is we're still going to be using those same methods that we did on the first 2 problems. We're still going to be either using elimination or substitution. And just like in those first 2 methods, what our goal is to take 2 variables and condense it down to just a single equation with a single variable. So if I have 3 equations and 3 variables right now, our first step is going to be trying to convert this or rearrange this, add this together, manipulate it in some way so that I can take these 3 equations with 3 variables and condense it down into 2 equations with 2 variables. And then I'll just repeat that process over again. Once I have it into 2 variables with 2 equations, I'm going to condense it down again using those same processes to get it down to just a single equation, single variable. So for example 1, which is box 3, I'm going to do this first one showing you elimination. But it's going to be up to you which method you prefer. Just like with the other systems we did in Algebra 1, I'll show you options for how you can solve it, but whichever one makes the most sense to you, as long as you can do that with a high rate of success, I don't care which method you choose. So the way that we would do elimination here is similar but a little bit different, because we can't just add 2 of our equations up and hope that the variables are going to drop away. What we have to do is try and figure out which variable is going to be the easiest to eliminate, because I have to make sure that I'm eliminating the same variable throughout my entire system. So if I have numbers that are close to each other or multiples of each other that I can easily manipulate, those are the ones I want to choose to try and get those to be eliminated. So our 3 different options here, we can look at our x values, we can look at our y values, or we can look at the z values. And here, I think it's kind of between 2 choices for me, and it really depends on your personal preference. Remember, for what we're trying to do for elimination, you want to have the exact same coefficient, so the same number, but one is going to be positive and the other is going to be negative. So it's up to you on which one you choose. I think my z's are the hardest one to get all to match, because you want to try and get it so that all 3 of those are going to be the same coefficient when you pair them up. And it's not easy to turn a 3 into a 5 or a 3 into a 4 or vice versa. For my x's and my y's, really it's personal preference here. I would say that my choice would either be using this 2, because 2 you could just multiply by a negative 2 to make it negative 4. 2 you could multiply by negative 3 to make it a negative 6, and then those would eliminate. Or you could use this negative y to get it to eliminate my other 2 options. So negative y times 2 would be a negative 2, so it would eliminate that. Or negative y times negative 3 would make it a 3y to eliminate with the equation right above it. I always tend to use the smaller ones, or if you have something that's just a y, an x, a negative z, something like that, I tend to use that as what I call my eliminator equation. So I'm going to go ahead and say that I'm going to eliminate y. That's going to be the one I'm trying to eliminate. Oop, that's still a highlighter. I'm going to try and eliminate y. And this bottom equation is what I call the eliminator. And then just so that I'm using the same words that you guys are seeing, I'm going to call this my top equation, and this is my middle equation. So what I have to do here to get my equation down to just a two-variable system, I'm going to take this eliminator equation, I'm going to highlight it in yellow here. I'm going to take this eliminator equation and pair it up with each of my other two equations. And I'm going to do it in a way so that my y values all get canceled out. So it is a little bit tedious because you have to do this in two separate stages. First, I'm going to pair up my top equation with my eliminator. So my top equation is and let's do this in different colors. Let's do the top equation in red. So here, 4x plus 2y plus 3z equals 12. And that's paired up with my eliminator, which is 6x minus y plus 4z equals negative 3. And I also have to pair it up with my middle equation. So my middle one, we'll do that in green. That one was 2x minus 3y plus 5z equals negative 7. Paired up with my eliminator, which was still 6x minus y plus 4z equals negative 3. So now that I have those two pairings, I'm going to try and eliminate the y value from both of those. So remember, for elimination, if I don't have something already matching positive, negative with the same coefficient, what I have to do is multiply one of my two equations, hopefully just one, by something in order to get them to match. So in this first pairing, if I'm going to try and get my y's to be the same, with one positive, one negative, I'm going to have to multiply that bottom equation times 2. When I do that, I'm just going to do a little squiggle line here. My top equation does not change. 4x plus 2y plus 3z, that's a weird 3, 3z equals 12. And my bottom equation becomes 12x minus 2y plus 8z equals negative 6. And you can see now, when I add these two equations up, my 2y and my negative 2y are going to get eliminated. And I'm left with 16x plus 11z equals 6. So then I'm going to go ahead and do the same thing with my other pairing, with my middle equation paired up with my eliminator. So I'm going to go ahead and figure out what I have to multiply by. Here again, make sure you have to get the coefficients to be the same digit, but with one positive and one negative. So right now they're both negative numbers, so I'm going to have to multiply the bottom equation times a negative 3, so that my top y value is negative 3, my bottom y value is positive 3. So again, my top equation is not going to change. 2x minus 3y plus 5z equals negative 7. And my bottom equation, when I multiply by negative 3, becomes negative 18x plus 3y minus 12z equals positive 9. So adding up, going down, my 3y and my negative 3y cancel out. I've got a negative 16x minus 7z equals 2. So that's the kind of the three variable part of this problem. I've taken what I have for three variables, three equations, and if you look at what we're left with now, those bottom two equations are two variables with two equations, which is this exact same problem we started with on the front side of our notes, the very first two boxes that we did. So what I'm going to do, I'm going to rewrite this in black. I've got my new equation I'm going to be working with. My new system is going to be what I was left with. So 16x plus 11z equals 6. And then negative 16x minus 7z equals 2. Now from here, you don't have to continue using elimination. You can kind of mix and match as you see fit, as it's easier for others. So here, it is still pretty easy to continue using elimination because you can see my x values are already set up nicely for elimination. One's positive 16x, with the other one's negative 16x. So if I was going to go ahead and just add up my equations going down, my x's cancel out. 11z and negative 7z is 4z equals 8. So I'm down to a single variable, single equation. I divide by 4 on both sides, and I get my first solution, which is z equals 2. Now it's kind of a domino effect. I have to go start working my way back up the problem until I get to a place where I have two variables that I need. I know what z is, so I'm looking for an equation that has x involved and z, or just y involved and z. So if we go back kind of up the process here, one of the next two equations that I was dealing with were the ones written there in black. So I'm going to plug that z equals 2 into one of those two equations. So I'm going to do that in red. So I'm going to choose this top one right here. I'm going to plug in z as a 2, and then solve for x. So when I do that, I have 16x plus 11 times 2 equals 6. So as I go through and solve that problem, 16x plus 22 equals 6. I subtract 22 from both sides. 16x equals negative 16. So x equals negative 1. 2 down, 1 to go. So from here, you're going to go back to one of your 3 original equations. It does not matter which one, but you know what x is, you know what z is, so now you're just looking for an equation so that you can solve for y. In this one, I'm going to use the eliminator equation just because that's usually the simplest place to find your y value. The last one that you're going to be solving for is the first one you eliminated. So I'm going to go ahead and use that eliminator equation. 6x minus y plus 4z equals negative 3. And in green here, I'm going to go ahead and plug in negative 1 for that x value, 2 for that z value, and then I'm going to solve that for y. So my original equation was 6x, so 6 times negative 1, minus y plus 4z, which in this case again is going to be 2, equals negative 3. So now I'm just going to go ahead and simplify and solve. Negative 6 minus y plus 8 equals negative 3. So negative y plus 2 equals negative 3. Minus 2 on both sides gives you negative y equals negative 5. So then y equals positive 5. Putting that all together, you have all 3 variables, but you do need to still list it in a coordinate version. So usually it would be x comma y when there's 2 variables. So now it's just going to be x comma y comma z. So in this case, my final answer would be negative 1 comma 5 comma 2. And that would be my final answer there. So that's a 3 variable system with elimination. Now, that's not the only way that we can do that. I will also show you how to do a 3 variable system with substitution as well. I know most people in Algebra 1 at least kind of tended more towards substitution as the thing they're most comfortable with. But I'll show you both options, and then again, I'll let you guys choose on which one you prefer. So for number 4, we're going to solve this one using substitution. So in substitution again, for that one, you're solving a variable in one of your equations and plugging that into your other equation, or in this case, equations, to get rid of that variable. So this one, for substitution-wise, I'm just looking for which variable in any of my equations is going to be the easiest to get by itself. And I think in this case, it's pretty clear to see this positive z in my bottom equation is the only variable that doesn't have a coefficient on it. So that's going to be the easiest one to isolate, to solve for. So all I have to do in this case is rearrange this bottom equation to get my z by itself. So I'm going to have to subtract 2x on both sides, subtract my 4y on both sides, and that'll give me z all by itself. So my new version of this bottom equation, z equals negative 2x minus 4y plus 6. That's my new version of that bottom equation. And now I'm going to do that substitution step. So I know what z is equal to in my bottom equation. So that also has to be what z is equal to in my other two equations. So in my top one again, I'm going to use red. In my middle one, I'm going to use green. I'm just going to substitute negative 2x minus 4y plus 6 in for x. So in my top equation, 3x plus 2y minus 3 times negative 2x minus 4y plus 6 equals negative 2. So you can see I'm just taking what z was and just substituting that in for z in my top equation. I'm going to go ahead and simplify this down a little bit. Obviously we have just x's and y's, so I can get that simplified down a lot more condensed than what I have here. So I'm going to start by distributing my negative 3 into all three of my parts of the parenthesis. So that's 3x plus 2y plus 6x plus 12y minus 18 equals negative 2. And now, to get everything condensed together, I'm going to collect my like terms on the left side, but I can see that my constant, my negative 18 that's over there, is going to have to get pushed over to the other side with that negative 2. So I'm going to also do that at the same time. So I'm going to add 18 to move it over, and then just add my y's together, add my x's together. So in total, I have 9x plus 14y equals positive 14. Nope, positive 16. So that's my new number 2 equation. 2 variables, 2 equations. So I'm going to do that same process again on my middle equation. So I'm just going to do a little squiggle here. My middle equation originally was 7x minus 2y plus 5z. So now again I'm going to write negative 2x minus 4y plus 6 equals, and this was originally negative 14. So from here again, same general process. I'm going to be distributing my 5 in here to all 3 pieces. 7x minus 2y minus 10x. That's an ugly x. Minus 10x minus 20y plus 30 equals negative 14. So from here, I'm going to go ahead and do the same thing I did before. I'm going to subtract my 30 to move it over, and then just collect up my x's and y's together. So in total I've got negative 3x, negative 22y, and negative 44. And that right there is my new 2-variable equation. So that gives me my new system that I'm solving is going to be, 9x plus 14y equals 16, and then negative 3x minus 22y equals negative 44. So again, up to you on how you want to continue with this problem. You could go to substitution again if you wanted to. In this case, I'm going to go ahead and use elimination. I'm going to be multiplying by a positive 3 in this case. Positive 3. because I want to get rid of my x's in this one. I'm going to try and eliminate x. So in this case, my top equation does not change. 9x plus 14y equals 16. And then from here, 3 times negative 3x would be a negative 9x. 3 times negative 22 would be a negative 66y. And 3 times negative 44 would be negative 132. So now that I got my x's coefficient matching, I can go ahead and eliminate those. And I add up going down. Negative 66 and 14 gives me a negative 52y. And then negative 132 plus 16 is a negative 116. So from here, super ugly answer. Divide by negative 52, divide by negative 52. The best we can do is reduce. They're both divisible by 4, so I can reduce this to a 29 over 13. Kind of ugly, kind of really ugly, but it is what it is. Sometimes we don't get the prettiest of answers. Don't let that kind of smudge your opinion of substitution. The process is not the reason why we have these ugly answers. It's the numbers that I chose for my equations, and that is what it is. So now that I have my y value, I can go back to one of my equations to solve for x. I'm going to use the top equation in this case, just because it's a little bit simpler to work with. So 9x plus 14 times 29 over 13 equals 16. So multiplying together, 9x plus 29 times 14 is 406 over 13 equals 16. So I'm going to have to subtract this 406 over 13 on both sides. 9x equals, let's see, so 16, I'm just going to do some scratch work over here. 16 would be 208 thirteenths. So minus my 406 thirteenths would be negative 198 thirteenths. So then when I divide by 9 on both sides, which is the same thing as multiplying by 1/9, 198 divided by 9 is a negative 22. So that's kind of nice. That reduces there, so that's just 22. So my x value ends up being negative 22 over 13. Not liking this problem at all. And then I go back to my top equation that had z all by itself. Z equals negative 2x, which we just saw was negative 22 thirteenths, minus 4y, which is 29 thirteenths, plus 6. So we've got, let's see, a positive 44 thirteenths minus 116 thirteenths, and just for the sake of getting like terms together, plus 78 thirteenths. That's just 13 times 6. So adding up everything all together, getting it all collected, and 44 minus 116 plus 78 ends up in total 6 over 13. Because 44 and 78 is 122, so 122 minus 116, it gives me 6 thirteenths. Very, very ugly. Not a fan of that structure there. Shouldn't say that. I'm not really a fan of how ugly that answer got. Most of the time, you should be getting whole number answers for what we're going to be working on, but it is what it is sometimes. Real world problems aren't always the prettiest, so you might have some problems where you're getting fractions or decimals, and that's just the reality of the situation. So make sure we still write our answer in order triple. So x comma y comma z, negative 22 thirteenths, comma, 29/13, comma, 6/13. I know that that's really ugly. I'm not a big fan of it. Again, I know the structure itself is not really far beyond where we're used to. It is a long and tedious problem, as you can see all the work that we have done just for that single thing. But take your time. You're never going to have that many of them to work on at a time. Your homework, which is the worksheet that I have posted in the classwork tab, it's just a worksheet that's got 5 problems on it. I think maybe 4 problems. So you just got a handful of those. But some of them, these ones that I gave you are as long as these problems are going to take. There are some of them where maybe one of your equations only has 2 variables in it. So then you only really need to do one elimination process before you get down to that simple 2-variable system that you're used to solving from Algebra 1. So that's all I got for you today. Just make sure, again, if you're confused, watch this over again. I went through a lot of steps in the process, and feel free to pause, rewind, and rewatch as much as you need to. And then if you're still confused on stuff, just have those questions ready to go so that as soon as we're together again, you can ask those questions. That's all I got for you today. Have a fantastic day. I'll see you guys again soon.